Hello and welcome to Singapore Math Course 2A 1.1 representing rational numbers on a number line. So here we will be doing the independent practice from this chapter. So let's get started with the first question. It says, find the absolute value of each fraction. Draw a number line to show how far the fraction is from 0. Write each fraction in the simplest form. Okay, so as you can see, you have to write each fraction in the simplest form and then we put it on the number line. So the first one is 7 upon 10. You know, when we divide by numbers like 10, 100, basically you write the number, your numerator as it is, and then you count the number of zeros. Here you can see that the number of zeros is 1. So 7 is digit 1 and then you put the dot. So that's the answer. So 7 upon 10 is 0.7. Let's go to the next one. The next one here is 18 upon 8. So how do we solve this? The best way to go about solving this is to actually carry out the division. So let's do it. 18 divided by 8. We all know what times tables, right? So 8 times 2 gives us 16. So we take out 16 from 18 and that leaves 2. Now 8 cannot go in 2. So what do? We put a 0 here. But remember, when you put this 0, you have to also put a decimal here. Now 8 times 2 again will give us 16 and then 4. Again, since 8 cannot go in 4, we are going to put 0. But this time, we don't need to put a decimal point again because we have already put the decimal point here, okay? So 8 times 5 gives us 40. And the answer here is 0, the remainder, right? So this quotient is the answer. So it becomes 2.25. Okay? And then we go to the next one. Now here, as you can see, it's a -1. But as we already said, it's the absolute value that we are talking here. So what are we going to do? We will write this as 5 over 13, the absolute value, right? Like this. And so we are going to take this as a positive number and calculate. Again, it's a simple thing. We divide it. Okay, so 5 divided by 13. Now, as you can see, 13 does not go in 5. So what are you going to do? Yes, you're going to put 0 here. And of course, the decimal point, right? So 13 times 3 is, yes, 39. And that gives the remainder 11. So what's the next step? 13 goes in 11? No. So we'll put 0. And 13 times 8 gives us 104. Remainder is 6. This can go on and on, okay? Or sometimes it stops. Now it's taking longer, but we don't need to go that far because we already have 2 decimal places. So we will stop here. So the answer here is 0.38. Yes? Then the next one. These 4 questions are similar. The first 4 questions. Then again, absolute value. So positive, right? Division. So 48 divided by 15. Do you know your 15 times table? So it's easy. Times 3, 45, and the remainder is 3. Put a 0 and a dot. It's times 2 makes it 30 and it's 0. Done. So the answer is 3.2. So all the 4 questions are done here, right? And then it says you have to put them on a number line. So how do we make our number line here? Let's make a simple number line where we can put all the answers together. Okay, so this answer is here. The answer from the first one was 0.7. Then we had 2.25. We had 0.38. And this is 3.2 here. So we have these four numbers to be plotted, right? So let's make a number line. Okay, so let me say this is my 0, my 1 here, 2 here, 3 and 4. 0.7, right? So it should be somewhere here. 0.7. So that's 0.7. Then 2.25. 2 is here. 2.5 would be somewhere in the center. So I'll go half of that. So that is 2.25. This is 0.7. Now the next is 0.38. Almost 0.4. Okay. So that would be somewhere here. 0.4. And finally you have 3.2. So this is how I can plot all the numbers on the number line. Isn't that simple? It's very easy, right? So, ready to move to the next question? Let's go. Here it says, write each integer or a fraction as m upon n in the simplest form, where m and n are integers. Okay, so you need to have a fraction, right? Like a ratio, m upon n. Here you just have 67. This is very simple to do. What you are supposed to do is simply write 67 over 1, because any number divided by 1 is always the number. It doesn't change. So that's it. It's the simplest form here. Moving to the next one. It's minus 345. Again, you just have to put it, divide by 1, and it's done. Okay? Now this one is not as simple as the previous one. So how do we solve this? I know 25 is 5 times 5, and 80 is 5 times 16 basically, right? So now you take out the common one. What are you left with? 5 over 16. This cannot be further divided. So this is the simplest form that you can have here. Understood? So let's move to the next question, number 8, which is minus 264 over 90. So how are we going to solve this question? We need to get the prime factors for this, right? Because we want to simplify it. So let's start with 264 here. Prime factors. So it ends with 4. So it's an even number. So we'll start with 2 here. So 2 times 1 is 2. 2 times 3 is 6. And 2 times 2 is 4. Again, it's an even number. We further go with 2. 2 times 6 is 12. But this is 13, right? So we put 1 here. So that's 6. Again, even number. So 2. And yes, 3, 3. That was a simple one, right? 33 tells us it has to be with 3 and 11. So these are the prime factors. So how do we write it? 2 times 2 times 2 times 3 times 11 over 90. We got to do the same thing for 90 here now. So 90, we start with 2 because it's an even number. So that's 4 times 2 is 8, and that's 9. So we have a remainder here, and that's 5, 45. So you can do it with 3 because 4 plus 5 is 9, and 9 is a multiple of 3. So let's go with 3 first. It's always good to go in the sequence. So 3 times 1 is 3, and then that becomes 15, and that's 5. So again, 3 times 5 and 5 times 1. So we'll say 2 times 3 times 3 times 5. And of course, remember your negative sign here. So next, what do? Yes, we cancel the common factors, right? We cross out the common factors. So 2 is common and 2 is common here, right? So we cross it out. We have 2 more here, but we don't have 2's anymore. Remember, if you cancel 1, 2 in the numerator, you cancel only 1 in the denominator, okay? Now here numerator has 2 more, but we're not going to cancel that because we don't have any more 2's in the denominator. Next is 3 and 3. No more cancellation. So what are we left with? minus 2 times 2, this one here, right? And times 11 over this two numbers here, 3 times 5, which is equal to, this makes it 4, right? So that's 44 over 15, and here minus sign. So that's it. You cannot further divide this. So that's in the simplest form over here. Isn't that easy? You just have to find the prime factors, cancel out the common ones here in this step, and then multiply whatever is left. Moving to the next one, which says minus 14 over 70. Now, if you know your times tables well, this is very simple, okay? So it's basically, you know that 14 times 5 gives us 70, right? So you can simply write this as minus 1 over 5 straight away. But if you don't know that, the times tables, then you have to simplify this. So 14 is basically 2 times 7. 70 is 10 times 7, right? So this is minus 2 over 10, which is actually, this is actually 2 and 5, right? So again, you will do the cancellation of the common terms. And what are you left with is minus 1 over 5. So either way you go, you're going to get the same answer. It's just knowing your times tables makes it faster for you. So that's the answer for this question. Are you ready for the next one? Yes, the next one is here. It says just 600 over 480. So in this type of questions, as we did before, we can just cancel this 0 and this 0. So it's actually 60 over 48, because this 0, 0 gets cancelled. Remember, this 0 doesn't get cancelled, okay? 1 0 in the numerator, 1 0 in the denominator. Again, as I said, if you know your times tables, this is very simple. This is 12 times 5, and this is 12 times 4, which is equal to 5 over 4, because this 12 and this 12 will be out, okay? But if you don't know your times tables, then you have to divide it, right? Like you have to go and get the prime factor. So again, this could be 6 times 10, right? So 10 is 2 times 5. And this one is 6 times 8. 8 could be written as 2 times 4. I'm not writing this further here like 4 as 2 into 2, because that's not cancelling. I'm just writing the numbers that will cancel out, okay? And that leaves me with 5 over 4. It's the same answer, right? So either way you go, you'll get your answer. But I will keep repeating as I do. Learn your times tables, because that's going to make your life easier. Moving to the next question, which is 7 over 9. Now it's a mixed number. So first we'll have to convert this, right? So this is times, and this part we add. So this is basically 7 times 9 and plus 7 over 9. The denominator comes as it is, right? So 7 times 9 is 63 plus 7, and again the denominator 9 here, which is 70 over 9. That's it. Done. Okay? Because this cannot be further divided. It cannot be further simplified. Okay? If you want to check, you can check. You can confirm your answer, because 70 is what? 7 times 10. And this 9 is 3 times 3. Right? This can be written as 2 times 5 also. Do you see no common factors? So this is the final answer over here. Moving to the next one. Watch out. Now we have a negative number here. So minus 5, 1 over 10. So we'll keep our minus sign here, and then this is multiplication and this is the addition. Right? By now you know it very well. So 5 times 10 and plus 1. Remember that. Upon 10, the denominator comes as it is, right? Which is equal to 50 plus 1 over 10 and the minus sign, which is minus 51 over 10, and it's done. It cannot be further divided. So that's the answer. again we have a mixed number. So what are we going to do? Yes, this will be multiplication and that's addition, right? You may actually want to pause the video and solve it yourself and then come back to see if you have the same answer. Up for the challenge? Go for it. Come on, tell me. 2 times 12, yes, plus 5 over 12, which is equal to 24 plus 5 and over 12, which is equal to 29 over 12. That's it. And done. Wasn't that simple? You had the same answer? Yes, you did. Great. Good, good, very good. Keep up the good job. Let's go for the next. So let me solve here. Minus sign. Remember, yes, 10 times 36, right? Multiplication, and that's addition. Plus 11 over 36. The denominator comes as it is, which is equal to minus here 360, then plus 11 over 36, which is equal to, just add it, right? So 60 plus 11 would be 71. So 371 over 36 and my minus sign. Very important. Did you get the same answer? You did. Good, good, very good. Keep going. Now we continue. Now what do we have here? We have the number in the form of a decimal number, right? And we need it in a fraction format. So what do? How are we going to solve this? Is it tough? It's complicated? It's not. It's very simple. If you have to write this as a fraction, how would you do it? Yes, you write 4 over 10. Yes, why? Because we have one decimal digit after the decimal point, right? We have one digit. So one digit, 1 0. If we have two digits, 2 zeros. Okay? And now this is a simple number. 4 is 2 times 2 and 10 is 2 times 5. And the common numbers are out. So what are we left with? 2 over 5. That's it. Done. If you want to confirm your answer, I'm just showing you some tricks so that you can also confirm, you can check whether your answer is right or not. Okay. So how do we check this? Let's take this fraction. 2 divided by 5. 5 does not go into, so we'll put a 0 and yes, the decimal point. Very important. So 5 times 4 gives us 20. And that's exactly what you have here. Okay, so this is the answer. So this is how you can cross-check if your answers are right or not. It's important so that you don't make any mistake. The next one. It's again a decimal one and we are going to solve it in the same format. So we write 625. How many zeros are we going to put here? Yes, it's 3 digits, right? So 1, 2, 3 and the minus sign. Now you have to solve this. So we need to get the factors. So let's do it here. 625. The factors, because it ends with 5, let's divide it by 5, right? 5 times 1 is 5, 1 carried here. 5 times 2 is 10, 2 carried here. And 5, right? 25. 5, 25, 5, 5, 5, 1, right? Same we do with 1000 because it's an even number. Let's do with 2. Okay, so 2. This is, of course, 500. We know half of 1000 is 500, right? Again, divide by 2. Half of 500 is 250. Again, divide by 2. Half of that is 125. Now, I can do this further, but I'm not going to do it because this number is exactly the same number here. So this will be repeated here, okay? So let's write it down. So 625 can be written as 5 times 5 times 5 times 5 over. Now here we have 3 times 2, right? So like 3 times 2, not like 3 times 2 in that sense, but 2 times 2 times 2. So it's basically multiplying 2 3 times. That's what I meant to say. Then we repeat this here. 5, 1, 2, and 3. Okay, and the minus sign. Now, what do? Yes, we cancel out the common terms. Now, here we have 3 5s and here 3 5s. So they are out. Now, we don't cancel this 5, okay, because that's only 3. So we cancel only 3 from here. So what are we left with? Minus 5 upon this numbers here, right? 2 times 2 times 2, which is 8. So that's your answer. So that's how you solve this. So basically get the prime factors and then cancel out the common factors and you'll get your answer. Aren't these questions very easy? Yes, they're super duper easy questions. The next one, again a decimal one. So 580 upon, what are we going to write here? Yes, do you know it? Perfect. Yes, we'll add 2 zeros here. And now, as the custom is, we cancel out this because that's 0 and 0. Remember, this does not cancel, okay? Because there's only 1 0 in the numerator. So how do we solve this? We have to get the prime factors. So it's basically 2 times 29 and this one is 2 times 5. That's 10. Okay? If you want to confirm, you can check here. 58. It's 2. 2 times 2 is 4. 1 carry here. So again, now 2 and 2 will be out, right? So what are we left with? 29 over 5. We need in the fraction format, right? So 29 over 5. And that's it. It's done. Now the next one. I'm going to make it 9001. Yes. Now here, tell me. Yes. 3 zeros. Now, what's the next one here? 10 and then 68 over 2 zeros. So now we will find the prime factors, right? So 1068 and the prime factors. Let's start even numbers. So we start with 2. 2 times 5 is 10. Then 2 times 3 is 6 and 2 times 4 is 8. Again, even number, we go with 2. 2 times 2 is 4, so 1 will be carried here. 2 times 6 is 12, 1 will be carried, and that's 7 there. Okay, now this cannot be divided by 2 further because it's an odd number. So let's try the next prime number, which is 3. So for that, what do? 2 plus 6 is 8. 8 plus 7 is 15. 15 is a multiple of 3. So this number is also divisible by 3. So 2 times 8 is 24. 2 here. And 2 times 9 gives us 89. And 89 is a prime number. So it will be divisible only by itself and 1. So let's write this here. It's minus 2 times 2 times 3 times 89 over 100. 100, do you need to do that or you know it? Let's do it just to make sure we are doing it right. 250, half of 100, right? Half of 50 is 25 and this is, of course, 5 times 5, right? So this is 2 times 2 times 5 times 5. What's the next step? 2 out. This 2 out. Do I have anything else to cancel? No. So this is 3 times 89 over 5 times 5. Do I actually have to go and do 89 times 3 here? No, I don't need to if I'm smart, right? What do? Look here, this gives the answer. So it is 267 over 25, and that's your answer, and it's a negative one. See, everywhere I was missing my negative sign. So that's it. Done. Simple. Yeah? Okay, so those questions are over, and we move to the next question, which says Locate rational numbers on a number line. Okay, now basically you have to plot all these numbers on a number line. How do we do that? The first and the important thing is that convert all these numbers in a format that is easier to compare them. Okay, like look here. This is a fraction, this is a fraction, these are decimal numbers. So comparison can become a bit tricky. So it's always good to convert them into decimal numbers. Now we know 1 over 4 is 0.25, right? It's given. This has some common numbers that we know. But if you don't know that, no worries, I'm going to solve here. So 1 divided by 4. 4 does not go in 1. So I'm going to put 0 and of course my decimal point. So 4 times 2 gives us 8. 2 is the remainder, again is 0. Now we're not going to put a decimal point again, right? Because we already have done it. And that's 4 times 5 gives us 20. So that's the answer here. Okay, this is decimal, this is decimal. 5 by 2 is 2.5, right? So if you want, I can do it here for you. 2 times 2 is 4. 1 is here. Remainder, I put 0 and a dot here, the decimal, and 2 times 5 gives me 10. And that's how I get my answer. Now, how do I plot them on a number line? So let's have a number line here. How am I going to label it? Let's first get the number line here. Let's draw it. Okay, so let's say this is our 0 here, right? Then this is 1. You can see that, right? 2, 3. I don't need to go much further because my biggest number here, positive number, is 2.5. So again, I'll go up to this here. Okay, now what do I need? 0.25 minus 0.25. So this is 0.5. So somewhere here. Okay, let me do it with a different color so that it's understood. So that's my first one. Then I have minus 1.5. So that will be here. Then 0.8. So that's 1. So 0.8 should be here. And then 2.5. 2 is here, 3 is here, so in the middle, right? So that's 2.5. So these are my numbers here. So this is 2.5. This is 0.8. This is minus 1.5 here. And this one is here. Here, okay? So that's 0, that's 1, that's 2, that's 3, that's minus 1, and that's minus 2. Okay, so using a ruler makes it easier because then you know exactly where you're pointing, right? Let's move to the next question. Again, it's the same kind of a question where it says you have to plot these numbers on a number line. And as I said in the previous question, it's always good to have it in the same format, all these numbers, so it's easier for us to compare them. So what's the first number? 1, 7 over 10. Because it's divided by 10. How many zeros? 1. So we put our decimal point here, right? Then this is already in the decimal format. This is also in the decimal format. Only this one is not. So let's convert this. So here we will do 13 divided by 5, right? So 2 times 5 is 10, which gives the remainder of 3. We are going to put 0 here. So we'll put a decimal. 5 times 6 gives us 30, right? So the answer is minus 2.6, right? Because it's a negative number. So we have two negative numbers, right? Which are this? This is negative and this is negative. And the other twos are positive. That's a positive one and that's a positive one too. So how are we going to put on the number line? Yes, we draw a line here and plot it. So let's get going with that. Now I'm not using my ruler. I'm just going to go straight like this, but I'm sure you will always use the ruler. It's always a good practice to use the ruler here. So what's the maximum I have? Positive is 2.25, right? So let's say this is 1, that's 2, and that's 3. Same here, minus 1, minus 2, and minus 3. So 1.7 will be like this would be 1.5, right? So 1.7 would be somewhere here. Fine. Then we have 2.25. So this would be 2.5. So half of it. So this way, somewhere here. So that's 2.25. And I have minus 2.6. Somewhere here in between would be 2.5. So I'll go a little further. So that's my minus 2.6. And now I have minus 0.7. So again, somewhere this is 5.5. So I'll take somewhere here. So that is minus 0.7. So this is how you plot them on a number line. Okay, it's very simple. Just convert all the numbers in the same format. Have them in the same format. Once you have them, you just start plotting them on the number line. And it's very simple, as you can see. Moving to the next one. It says graph each rational number on a separate number line. It's the same kind of a question, but here now instead of giving you 4 or 5 numbers to be plotted on the same number line, they're giving only one number to be plotted. Okay, so what are we going to do? We are first going to convert this into a decimal number. Okay, so now 67, we don't need to do anything. We'll just play with 1 over 8. So if you divide 1 by 8, it can't go, right? So 0.1 minus 8, 2, 0 times 2 is 16. 4, 0 times 5 is 40, right? So this is basically 67.125. So now how do we put this on a number line? Let's draw number line. Please make sure you're using your ruler, okay? Now how do we go about doing this? So let's say this is 67.10. Okay? This is 67.11. This is 67.12. It's bigger than that, right? So 67.13. Now 1, 2, 5. So this will be somewhere here in the center, and that's how you plot it. Okay? So that's how you do this here. Let's go to the next one. What does the next one say? It's 305 divided by 20. So again, you will have to get a decimal number. So the fastest way to do this is this way. 305 divided by 20, right? So we'll take 2 digits here. So 20 times 1 is 20, gives the remainder of 10. You put the 5 here from this, and then 20 times 5 gives us 100. Remainder is 5. We have no more digits here, so we're going to put 0 here and a decimal here. Now 20 times 2 is 40, which gives the remainder of 10. We put 0 again, but no decimal. We've already done it once, right? So 20 times 5 gives us 100, and the remainder is 0. So the answer is 15.25. So number line, yes. How are you going to start labeling it? Are you going to do 0, 1, 2, 3? You don't need to do that, you know now, right? So let's say this is 15. This is 15.1, 15.2, 15.3. Now 2, 5 will be here in the center, right? So it's 2, 21, 22, you go on. And so in the center here is your number. That's how you plot it. As we did in the previous question, try to go deeper, try to spread it well so that it's easier for you to mark and it looks neat and clean. Okay, now moving to the next one here, which is 98 upon 28. Now this requires times tables, so it's basically 14.7 and this is 14.2. So 14 out, and you're left with 7 over 2, which is nothing but 3.5. Okay, I could do this faster because I know my times tables, and if it's a problem, if you don't know, no worries. I would still say learn. If you can, amazing. If you can't, opt for this method. You do the factorization, right? It's an even number, so we start with 2. 2 times 4 is 8. 1 carried, 9, right? And we know 49 immediately tells us this is 7 times 7, right? So we can write 98 as 2 times 7 times 7, and then 28 is 4 times 7. You know that, right? So 2 here, 14 here, 2 here, 7 here, 7 and 1. So it's 2 times 2 times 7. So let's cancel the common ones. 2 and 2 out, 7 and 7 out. So what are we left with? 7 over 2, same as this. So either way, you are going to get your answer, right? But knowing your times tables makes it easier and faster. So the number line here. So let's say this is 3, this is 3.1, this is 3.2, this is 3.3, 3.4, 3.5, 3.6. Here is my answer, right? That's how you mark it. Done. Simple. Silly pilly. Yeah. Okay. Now comes this one. Minus 21 over 12. So again, these are simple numbers that I'm sure you know how to do it, right? So I'm going to go faster here. 3 times 7 over, and this is 3 times 4. So we cancel 3 and 3. What are we left with? Minus, and that's 7 over 4. So 7 over 4 is how much? Right? 1 times 4, 3, 0. Point, yes, 7. 4 times 7 is 28, 2, 0. 4 times 5 is 20, and that's 0. Done. So the answer is 1.75 with a minus sign. So how are we going to plot this here? Let's go. Right? So let's say this is 0 here because it's a minus 1, right? So I need towards the left, okay? And this is minus 1, minus 2. So minus 1.5 would be here. So again, the middle of this. So that's where I would plot it. Or if you want to go further. So let's say this is minus 1, minus 1.1, minus 1.2, minus 1.3, minus 1.4, minus 1.5, minus 1.6, minus 1.7, minus 1.8. So 7.5. So this would be here, right? Or even further, even further. Yes, even further. You heard me right. So it's minus 1.7, minus 1.71, minus 1.72, minus 1.73, minus 1.74, minus 1.75. Okay, so this is how you can plot it. It's simple, right? Plotting is much easier. You just have to get the right number. And the next one here, it's already in the decimal format. You don't need to do anything. You just have to simply plot it. So how are we going to do this? Where do we start? Should we say this to be minus 25? So this will be minus 25.1, minus 25.2, minus 25.3, minus 25.4, minus 25.5, minus 25.6, minus 25.7, and finally minus 25.8. Done? Simple. And the next one. It's already decimal, so we just have to start plotting. This one is a smaller number, so minus 45, minus 45.1, minus 45.2, and minus 45.3. I can write this here. Okay, that's it. The answer was already given. It was just putting it on a number line. So that's done with the first 27 questions, and we are on the last one. Okay, let's see what does the last one say. A video game gives you 10 minutes to find some treasure. Is 10 minutes enough? I don't play video games, so I don't know. But I'm sure you know it because you play. You do, right? The numbers below show the amount of time left when you have found the treasure for each of 8 games. So how many games are they having in total? Yes, they are having 8 games. The negative time means you have gone beyond 10 minutes. So if you take anything greater than 10, you will have a negative number. Use these data to answer A to H. So we have how many negatives? Let's see. You have 1, 2, and 3 negatives. Oh my God, out of 8. The person needs more practice to play video games. And the positives, 1, 2, 3, and 4. And this one here, it's the exact time. Okay? So we have 3 negatives, 4 positives, and 0 where the person has taken exact time. So what does the first question say? Order the times from most to least time left after, okay, left using the symbol this. So how are we going to do? Most to least. So this is the time left they've given, right? Because negative ones means you have taken more than that. So what numbers are we going to consider? We are only going to consider positive numbers, okay? Only positive, no negative, because negative means you have taken more than 10, which means you have gone beyond time. There is no question of having extra time, right? So let's start having the positive numbers from most to least. So the biggest one here is 8, greater than 7.8, greater than 6, greater than 23 by 8. Well, I wrote 23 by 8 because I know what's the answer for that. But before you start solving, it's always a good practice to do this. So 8. It goes 2 times 16, which gives 7 as a remainder. You put 0, then 8 times 8, right? Gives us 64. Remainder is 6, 0. 7 times 56, 4, remainder 0, 5, 40. Right, so I know that this is going to give me somewhere between 2 and 3. I was sure about it, so that's why I just went with it, okay? But it's always good to convert so that you know you are doing it right. So this is the answer for part A. Simple. Ready for part B? Let's see what this says. Write the absolute value of each number. Absolute value, which means treat them as their positive numbers. Okay, so that's like this one here, right? So we put a symbol like this to say that that's an absolute value. So it's simply saying 7, 1 over 5, 17 over 4, and 9.1. That's how you do the absolute value for this. Okay, now which number has the greatest absolute value? Now for that, it's difficult to compare this, but if you are smart, you can, because it is 7 point something, right? Actually, it should be 7.2, because 1 by 5 is 2. If you want, I can show it here. Not possible, so you put 0 and here. So 2. Done. Okay? Now 17 divided by 4, it should be something around 4 point something, right? So let's check that. 17 divided by 4 times 4 gives us 16. One remainder 0 0.2 gives us 8 to 0.5. Okay, so this is 4.25. This one here, and that's 9.1, right? So the biggest one, of course, is 9.1. The absolute value for this will be the biggest. Now, what does the next question say? Order the absolute values from least to greatest. Okay, so for all of them, now we consider as if they all were positive numbers, right? Because we're doing absolute value, and we have to start from the smallest to the biggest. So do you remember the answer for this? It was, yes, 2.875. We did that, right? We did that calculation. So we have all the numbers in the decimal format, so it's easier. So of course, 0 goes first because we are taking absolute. So 0 less than. Now, which is the next number, the smaller number? So that is 2.875. So we are going to write 23 over 8. So let's just cross out the numbers that are done. This is done, this is done. Now, we go to the next one. Which one is the next one? We'll have to go to this. So which is less than, right? So we are taking the absolute value, 17 over 4. So we cancel off this number also because we have already taken that. Then the next one on the list will be, now this is 7.2, this, so let's say it is 6. As we write, we just cancel them so that we know those numbers are done. Okay, so the next one on the list would be, well, we left with 7.8, 7.2, 8 and 9.1. 4 numbers are done, right? So 7.2 is 7, 1 over 5, which is less than. Next number would be, let's cancel this, and the next is going to be 7.8. So I'm already canceling that beforehand. 7.8, which is less than 8, less than minus 9.1. Okay, so this is how you order them, the absolute values from least to the greatest, and we have used the symbol less than as they have asked us to use. And here we are on the last part of this question, which says graph the original numbers. Okay, remember, you have to be very careful. It says original numbers, so no absolute values. Negative is negative, positive is positive. Okay, so let's start putting them on the number line. So remember to use your scale to make the number line. Here is my number line. Let's say this is 0. My biggest positive number is 8 and this negative number is 9.1. So let's see if I can fit it. 1, 2, 3, 4, 5, 6, 7, 8. Yes, I did it. Now here, -1, -2, -3, -4, -5, -6, -7, -8, -9. Just did it, just. Okay, so what are the values? 23 by 8. First, let's go there. That was, 2.875, right? So 2 is here, 3 is here. So it should be very closer to 3. So let's say somewhere here. So that's 2.875. Then we have 0, simple. Then -7, 1 by 5. That was basically 7.2, right? And it's a negative number. So 7 is here and 8 is here. So somewhere closer to 7. So that is -7, 1 over 5. Then the next number is 6. Whole numbers are very easy to mark. Then 17 over 4. What was the answer for that? It was 4.25, right? And that's also a negative one. So 4.25. 4 is here, 5 is here, -4 and -5. So this would be 4.5. So somewhere here, right? So that is -17 over 4. Then the next one is 8, the whole number. Here, 7.8. So somewhere here, 7.8, right? Closer to 8. And then I have minus 9.1. So somewhere here, minus 9.1. So I've marked all my numbers, right? 1, 2, 3, 4, 5, 6, 7, 8. I've marked all my numbers here. So that's how you'll mark it, the original, no absolute values. Now, which negative number in the list is furthest from 0? What are we talking about? Negative number, and that's the furthest from 0. So we are going to look on the left side of the 0, right? On the left side, which is this side. So furthest is 9.1. That's the furthest there, right? Which positive number in the list is closest to 10? Okay, the 10 would be somewhere here, right? So that's 9 and 10 would be further. So the closest would be the 8. 7.8 is little further away, okay? If you compare both. Which time is closest to minus 5? So we are talking about minus 5 here. So which is the closest? If you look here, this is 7.2 and this is 4.25, right? So this one is the closest to that. So it is minus 17 over 4. So that's how you solve this. So no matter what kind of questions they ask you like this or more, if your number line is done well, if you've plotted things well, you should be able to answer all these questions very easily, very fast. So that ends with the chapter. We've done all the questions and I'm sure it went well for you. I believe that you think it's easy now. You can solve it. You have gained some confidence. You need more practice. Come back, watch again and practice more. Do remember to watch out all the other videos for all the other independent exercises that we have so that you practice enough and you score really well. Thank you. See you in the next video. Bye-bye.